Hello, hi everyone. I'm Nancy, and thank you for joining us on the OWASP DevSlop show. Today, we're talking about security analysis of our infrastructure as code with Christophe Tafani-Dereeper. So, welcome. Bonjour, Christophe.
Bonjour Nancy, how is it doing?
Excellent. So, tell us a little bit about your plan for today.
Yeah, sounds good. So we're going to discuss mainly four topics. The first one is going to be how we can come up with a security baseline, specifically for cloud security. Then how we can use different tooling in the open source landscape to scan for our Terraform's code. And then we'll talk a bit about drift detection, drift prevention. And finally, we will finish with a few notes on runtime scanning as well.
That sounds great. Let's get started.
Hello again, I'm Stephania, and today I'll be co-hosting with Nikki Becker and Rosemary Wong. Hello, ladies.
Hey, everyone.
Hi. For those who are not familiar, I'm Rosemary Wong. I'm guest hosting on today's episode. I'm really excited for it. I'm a developer advocate at HashiCorp. I cover a lot of the tools, but you'll find me speaking and writing a lot on infrastructure testing.
Welcome, Rosemary. If you are new here, please make sure to subscribe to our channel and enable your notifications. References to what we'll discuss today will be added to the description box below.
Today's guest is security engineer and self-proclaimed security researcher. Christophe is passionate about information security, cloud-native technologies, and especially the intersection of both. He holds a blog where you can sometimes read posts about various unrelated topics ranging from cloud security to low-levels Windows hacks or CTF write-ups. Welcome, Christophe.
Hi, thank you. Thank you. Super nice to be here. So let's get started. Cool. So yeah, as I said, today we're going to discuss four topics, and we're going to go from the baseline to how we can scan our Terraform code, then towards drift detection, and finally talking a bit about runtime scanning. So my name is Christophe. I already had a very nice introduction, but I'm based in Switzerland. I'm French, which you can probably tell from my wonderful accent. I will not try to fake a good English accent, so just deal with it. And I'm working in the security team of a Swiss software company called NextLink. So yeah, it's 2021. We have a lot of people, of applications that are moving to the cloud. So in this context, we want, as security practitioners, we want to try and understand what are the main risks and how we can mitigate them. This is a report from the NSA from 2020. And basically what they discuss here is the fact that the number one risk in the public cloud is misconfigurations. It's not going to be 0 days, it's not going to be APTs, it's mostly going to be misconfigurations and poor access control. So in this context, we have a few resources that allow us to kind of try and understand how other people are getting compromised. So there is this very nice talk from Rami McCarthy, where he talks about a bunch of AWS-related incidents and why they occurred, with links to other resources as well. And if you go back to these resources, what we see is that obviously it's going to be a bunch of open S3 buckets, some security groups that are open to the internet, some server-side request forgeries, vulnerabilities that are leveraged to steal some instance credentials, and some overprivileged IAM roles. And sometimes it's also going to be a combination of them. Typically, if you look at the Capital One breach, it was a combination of internet exposure, SSRF that was used to steal the credentials of an instance, and an IAM role that was too privileged. So now, if we look at how we used to do security a few years ago, it looks something like this. We design our software, we implement it, we test it, we deploy it, and we operate it in production. And then at some point, we figure out, okay, let's do a pen test for this thing. Now we get some security findings, and we are back to square one because we need to design it, to implement it, test it, deploy it, and operate it. So it's bad from a planning perspective, and also bad from a risk perspective, because it means that the time window during which we have a vulnerability in production is pretty wide, typically going to be days, weeks, or even months maybe. So what people have been trying to do in the last year is to shift left on security. So what this means is just basically try to care about security early on. And it's also very applicable not only to security, but also to quality testing in general. So anything from performance to architecture and these kind of things. Now, when we say shift left, obviously there's a bit of buzzword. So I want to stop for a few seconds and discuss a little bit about the hype around shift left. So in security, shift left is very hypey, but in reality, in a lot of other industries, it's been a major challenge for decades. If you look at the car manufacturing industry, these industries, they have a lot of financial incentive to make sure that they are shifting left already, because if they ship you a car that breaks in 2 years, it's very expensive for them to get it back and to ship a new one to you. So there are a lot that we can learn from these other industries, and even actually in the frame of software engineering, we can find some references to shift left testing as early as 20 years ago. So also something else about shift left is that shift left is going to help, but it's not going to be a silver bullet. So typically, if our development pipeline is insecure, if we have a culture where people don't care about security, just throwing a bunch of security tools at our developers is not going to help, because we are trying to fix the symptoms instead of the root cause. And this is a very nice talk that Jeremy Matos did a few days ago at OWASP Geneva, where basically he talks about this and how some strategies to try to make sure that shifting left is not just a buzzword where we keep giving a bunch of findings to developers. Now, if we go back to cloud security, this is what typically a pipeline is going to look like. We're going to have infrastructure as code, maybe defined as Terraform. Today, we're going to focus on Terraform and AWS, but it's mostly applicable to a lot of other things as well. So we have our Terraform code that we are going to deploy inside a test account in AWS, and eventually it's going to end up in production. So when we say shifting left, it's really about starting from some tools that are pretty popular, like Cloud Mapper, Prowler, Scout Suite, and cloud security posture management offerings, to go from there and to shift left on tooling that we can use to scan our infrastructure as code for security issues, to make sure that we can find security issues before they get in production. So we're going to start with talking about what to scan for. We want to scan a security baseline. We don't want to scan for everything. Then we're going to take a look at some open source Terraform scanning tools. And then we're going to talk about drift detection and drift prevention, and we have a very special guest as well. And finally, we have some closing notes about runtime scanning, so scanning what is running in the AWS account. Right, so if you talk to people that have a strong background in application security, generally what they tell you is don't try to scan for every possible security issue and start with a baseline that makes sense for you. So typically what is recommended is to start from baseline of checks that are high signal, low noise. It's a fancy wording to say basically things that are easy to detect and that don't yield a lot of false positives. So it can be things like making sure that we don't have security groups that are open to the internet, or making sure that we don't have policies that are super overprivileged. And something that is really important here as well is not to keep this under our security silo, but to make sure that we can share it with the rest of the organization as well. Because in the end, the end goal is not to find security issues in Terraform code, but it's really to make sure that we can have infrastructure as code secure from the very beginning. Just something to consider. So a few resources for that. We have a nice blog post by Chris Farris about how to create a cloud security standard. He talks about his experiences on that. Then we have some AWS specific resources. trusted advisor security checks, AWS security pillar, and AWS config manage rules. So these are not how we are going to scan for these issues, but it's just some inspiration that we can take for checks that can be useful to us depending on what we want to focus on. And we have also the CIS benchmark to some extent. Some of it will be relevant, some of it will be maybe a bit less relevant if we use a modern multi-account setup. And finally, we have the checks that we have in the open source tools that we will see in a few minutes. Now, I want to pause for a bit. If you know, Clint Gibler is the maintainer of TLDRSec, and he likes to talk about insecure or secure defaults. And basically, the point is that if we have insecure defaults and we try to fix the vulnerabilities instead of insecure defaults, we are just going to end up playing whack-a-mole, basically fixing vulnerabilities and waiting for them to reappear because we didn't fix the root cause. And a lot of it is also applicable to infrastructure as code. Typically, when we look at the AWS resources for Terraform, if you create a S3 bucket, by default, it's going to be unencrypted. We won't have any logging for it. It's not going to be versioned. And we won't have any public access block that is going to save us if the bucket policy is screwed up. So the idea here is to try to leverage also infrastructure as code modularity. So creating Terraform modules, for instance, and to create things that can be reused across the organization in a way that makes sense. So typically, it can be providing secure defaults with regards to our baseline, things like encrypting stuff at rest by default and not requiring an explicit parameter for it. And maybe abstracting away things like creating a public access block for S3 buckets, auditing where to send the logs, choosing the right KMS key depending on the sensitivity of the data, and things like that. There are a lot of great ideas in this talk from Clint. It's probably my favorite AppSec talk, so I recommend that you take a look. It's a great one. Okay, so I think we have a first slot where we can maybe exchange a bit on the pros and cons of shifting left, about your own experience as well. And yeah, feel free to jump in if you have some discussions.
Stefania, I feel like you're muted. So
Oh,
please.
sorry, I
You
I
were-
had myself on mute.
Okay.
Sorry. So I was saying, I have to remember now. I really liked what you were saying about the silos. So having like security and engineering, and if you're going to have these rules and making sure that things aren't overprivileged and sharing it with the engineering. So what kind of tips do you have for breaking down those silos? Because we often see them a lot between security and engineering.
Yeah, that's a good question. So I think a lot of it boils down to basically trying to speak the same language. So if you know that your engineering organization uses a specific documentation system or a specific version control, I think it makes a lot of sense to try and have basically this documentation at the same place where they are used to work. And also it shows that basically you know how they work and where they are going to search for guidance. So I would say that this helps, and also trying to be very specific. So not just saying typically that you want to encrypt S3 buckets, but also how you need to do it in the Terraform code, maybe providing some code samples. And yeah, from my experience, at least, trying to basically speak the same language and not just trying to give some recommendations that you don't even know how to implement, make a lot of sense and help for it.
Cool, thank you.
Yeah. So something that I observed is that, and I get this question a lot, is that do you have to have infrastructure as code in order for the shift left approach for security to work, right? Can this be done without infrastructure as code? Have you seen anything in your experience that requires the adoption of this versus not requiring it at all?
So you mean if when we talk about shifting left, it's also applicable to other parts of software and not only infrastructure as code?
So some folks will say like, hey, I have maybe data center infrastructure. It's not cloud infrastructure, but it's data center infrastructure that I've manually configured. And I don't know if I can do the security testing strategy, in that approach. So is it a valid thing to say you can only shift left if you do infrastructure as code, or is there a way to possibly apply these practices without needing to do configuration, inversion control, and all of the practices?
Yeah, well, I guess shifting left is just a fancy term to say try to get quality right from the beginning. So as we discussed in the slides, it's not something that is specific to software or even to computers. So I guess it's mostly in terms of process and trying to make sure that you are validating what you are building early on. And also it kind of resonates for me with the three ways of DevOps from the Phoenix project. And the second way of DevOps is trying to have short and amplified feedback loops. So I guess a lot of it boils down to making sure that you don't build something for 3 months and then someone tells you that you need to change it, but mostly try to have a lot of small iterative feedback loops. So in this context, I guess it's something that we can do in a lot of situations, even things that are not related to computers. Yeah. Definitely. Good. So I think we can move on to the next part. Great. So now we have a good idea of what we want to scan because we have our security baseline. Now we are going to take a look at some of the open source tools that we have at our disposal to try to scan for that. We're not going to spend 2 hours discussing that because there's a lot of tools, a lot of details. So we're going to mostly talk about criteria, and I have a blog post where there are more details around how each tool works and what we can do with it. You probably know some of these logos: Chekhov, Regula, SendGrep, Terraform Compliance, Terrascan, TFSec. They are all great tools. They are all open source. We also have some that are commercial, but we are not going to discuss today, but they do exist. Things like Palo Alto Prisma Cloud or Indeni Cloud Rail, this kind of things. So when we compare different tools, what I like to start from is to start from criteria. And here, a few criteria that make sense is first, do we want to scan for the Terraform code or do we want to scan for the plan? Then in terms, obviously, of how mature is the tool, who is it governed by, how widely is it adopted? And then we want to see if the tool has some built-in checks. So does it have a bunch of checks for AWS, Azure, or GCP that we can pick from, or do we need to write our own custom checks? In this case, we want to understand how we can do it. Is it in Python? Is it in the Rego language? How can we test it? And finally, how easy is it to use for developers, and how can we integrate it inside CI/CD pipelines? So we're going mostly to talk about 3 of them, but I think all of them make sense to consider. So scanning the Terraform code versus the Terraform plan, this is going to be a big one. So if we go back to our first slide, we had this where basically we discussed some common misconfigurations that do get people breached. And actually, if we look at how this is translated in Terraform code, most of the time, it can be very easy to spot. In this example, we have S3 bucket, and we are going to define the ACL on it to be public read-write. Obviously, this is pretty easy to catch. If you are using grep or anything that supports matching strings, it's pretty easy to see that this is a security issue. Now, if you use Terraform for long enough, you know that it looks more something like this, where you have a bunch of variables, dynamic data types, and references to other things. And by looking at this, so for instance, here I'm indexing a map with a variable. So just by reading at the code in isolation, I cannot know actually if it's a security issue or not, because I don't have any context. So I'm missing context. So the other solution is to scan for the Terraform plan. The Terraform plan, for those who are not familiar with Terraform, is basically when you are running Terraform, it's going to compare what you have defined in your Terraform code versus what is running inside your AWS account. And it's going to tell you, if I want to reach this, I need to create this resource, or to change this parameter. So you need to be authenticated against where you are deploying your infrastructure, if it's with AWS, for instance. And then you are running Terraform plan. It will generate the plan based on that. So if we go back to our previous code, it's going to basically translate anything that you have in the code inside something that has been basically evaluated, interpreted. So you won't have any weird variable or fancy data sources here. You will have really the end values that Terraform will use. So it makes it easier to match on strings, for instance. Something else to consider is the use of child modules. So typically, if we use a Terraform module, here we are using the public Terraform module for AWS VPCs, is going to abstract away from us what resources it's creating. Here, I'm creating a bunch of private subnets, public subnets, but I don't really know under the hood what the module is creating. And if I want to understand that and scan it, I need to look at the plan. And that's specifically interesting if we are using a lot of Terraform public modules. This is a nice post from Bridge Crew. They are the makers of Chekhov. And they basically scanned the whole Terraform registry. And they found that quite a lot of Terraform modules are not, let's say, optimally configured security-wise by default. So something to consider as well. Summing up, do we want to scan the Terraform code or the plan? Well, obviously, it depends, as always. Scanning the Terraform code is going to be faster. We don't have to be connected against AWS. We don't even need an internet connection. But scanning the Terraform plan will allow us to have, to detect more things that we couldn't have because of interpolations and because of chaining modules. Obviously, at this point, we want to maybe to scan for both, scanning for the code and the plan. And for this, we have limited tooling that supports scanning both the code and the plan. So if we look at the different tools, we have basically Chekhov that supports scanning the code and the plan, which is really nice. We have Regular and Terraform compliance that are going to scan only for the plan. Terrascan and TFSec, they are going to focus on the code. And SemGrep is going to be basically not focused specifically on Terraform. So you can use SemGrep against any kind of structured data source. So we can scan for the code and the plan, but we'll need to use two different set of rules. Now, if we look at the built-in checks library of these tools, it's a bit different depending on the tool. So Chekhov, Terrascan, and TFSec, they have a bunch of checks for all the three major cloud providers. While the Regular, Terraform compliance, and SemGrep, they don't have much. They have a few examples, but it means that if you use them, you will have to start basically a bit more from scratch, which can be fine. Huh? Since we know that we are not trying to scan for everything and we want to have a baseline that makes sense for us. So we don't want to take all the 5,000 checks from a tool and to run them. And finally, yeah, the support for the custom checks. So also this is going to change depending on the tools. So Chekhov is going to do it with Python. And basically, there are some tools that want us to be able to write custom checks easily at the cost maybe of some expressiveness. So typically Chekhov, TFSec, and SemGrep, they are going to allow us to write checks in Python, YAML, and in a SemGrep DSL, which makes it easy to write, but makes it maybe a bit more limited in terms of expressiveness, typically for multi-resource correlation. And Regular, Terraform compliance, and Terrascan, they are going to use Rego and a DSL, which makes it maybe, in my own opinion, a bit more complex to write, but also it gives us more expressiveness as well. Looking at a few code samples, this is what Chekhov custom checks looks like. So it's basically just some Python code where you have to create a class, you extend a base class, and then you define to which resource your check can apply. And you have a method that is going to return failed or passed, which is pretty nice because it allows you to write unit tests as well. So you can have typically a Git repo with your custom checks and next to it some unit tests, which makes it basically treated as software. Regular, so it uses the OPA language, the Rego language, which is the OPA one. So in this case, it's pretty simple, but basically we can say it applies to S3 buckets, and we want to deny the resource if something matches. And Terraform compliance is an interesting one. because basically it uses the BDD language, which is some kind of natural language like rule language. And so a rule that you would write in Terraform compliance looks very much like natural language. So here, this is the rule definition. It would say, given I have an AWS S3 bucket, then it must contain this attribute, which makes it quite easy to read. So something to consider as well. And the final one for comparing the different Terraform tools that we have is also the usability and the developer experience, because as security people, obviously the developers, the engineers, the makers, they are our customers. So we want to make sure that they can use the tools at their disposal. And here, 2 criteria. First one is going to be, are people empowered to suppress the false positives or the things that they consider is not relevant? And second one is, how readable is going to be the output of the scans? This is an output of TFSec, which personally I like a lot. It's going to tell you exactly in which file the security issue is, at which line, in going to highlight it, and give you some actionable insights, so to the TFSec documentation to tell you how to fix it. So this is something that you can easily throw in a CI/CD pipeline without much work. Then you have something that is maybe a bit more raw, but makes it also more extensible. So regular, the output of the scan is going to be a JSON file where you will have different rules and if they passed and if not, against which resource they failed. So this is a bit harder to just give to a developer, but it makes it also easier to maybe write a wrapper around it to generate a custom report. The text suppression is really about trying to allow people to suppress some findings directly by annotating their code with a comment. So here, this is the format for Terrascan, where we say, Terrascan, we want to skip this specific check. And the reason is that we know that this is a S3 bucket that is for public static assets, and we don't really care about this. So when we run Terrascan, it will show us that this violation is going to be skipped. And as security practitioners, also it means that we can go to our source code repositories and just scan for these annotations to try and understand what checks people are skipping and why. In terms of tools, there is at least Chekhov and Terrascan that support this, which is pretty nice. I don't believe there are a lot of other ones. Now, in terms of challenges and areas for improvements for the tooling, this is my personal experience, and I hope you will be able to share also some of yours in the comments and with the hosts. So as I said, the limited tooling that supports scanning the Terraform code and the plan, which is a shame, but for those who support it, it's pretty nice. Also, when we are trying to scan 100 CI/CD pipelines, it's pretty challenging to keep track of which checks are failing when, if they are considered as false positive, what noise they are making, etc. And typically, currently, this is solved by commercial tools, but we don't have much in terms of open source for that. Another thing that is that can be interesting is the lack of warn versus break the build capabilities. So typically, it's interesting to be able to have rules that are going to trigger some warnings and other rules that are going to break the build in a sense. And this is not something that we have currently, as far as I know, with the open source tooling that we discussed here. ID extensions. So Bridge Crew, they did release an ID extension for VS Code, but it's not working with their Chekhov open source part. So we don't have much in terms of open source tooling that allow us to scan for the Terraform code directly inside the IDE. And maybe it's something that we'll see in the future that would be super nice. And finally, something that we are missing and that would be super useful is also the ability to scan for only the resources that changed between 2 different commits. Typically, this is nice for pull requests to make sure that you are just scanning what the people changed. And it's also nice when we try to integrate scanning inside a new repo where we have some security flaws that we know and that maybe we want to fix later on, but at least to try to focus first on making sure that we don't introduce new things, new security issues without having to scan and to fix for all the other ones that are already there. So yeah, I think we can have a quick break on that, and maybe some comments on the landscape of Terraform scanning tools. Maybe your experience also scanning the code versus the plan, and if you have some changes of integrating these inside CI/CD pipelines.
Yeah. Go ahead, Rosemary.
Go ahead, Nikki. You haven't asked the question yet.
No, I mean, I think this is a great topic. All of those like software products, open source tools that you've just went through. Like, I think we've all probably, a lot of us have evaluated most of them. I guess I wanted to get your take on, it's clear when you have like 000 on port 3389, like that's probably a violation of something. It's definitely not good practice, etc. What about the more, like the less clear ones, the more gray ones, like IAM stuff? Like maybe you really need a star role for something, or maybe you really need that role for another thing. And it just gets less clear as to whether it's a violation or not. How do you reason that? The less clear violations?
Yeah, that's a good question. I guess it boils down as well to the approach of as security trying to be guardrails and not blockers. Because typically here, as you said, there are some cases where we are going to need some role to have these specific permissions. Maybe because the vendor tells us that we don't have a choice. Maybe it's because AWS tells us that we need to use this. So personally, I think it's a good idea if we can have it by default. So by default, we have a guardrail that is going to prevent us from making a mistake, but to empower the developers, the engineers, to suppress this check and to say, no, this is not relevant. And I'm the one who knows it better because I'm the one who is developing that.
Yeah. Yeah, it makes sense. I mean, I think I've sort of gotten to the place where elevating the fact that this IAM role might be a little weird is enough to have the discussion as to whether or not it's weird. And then that's good enough to proceed, right? At least it, sort of spots it, and then you can evaluate and contextualize it. So yeah, cool. Thanks.
Cool. Do you have some more? So we have a question from Mohan. When is the right time to run these Terraform scans? So it's a good question, and I think it boils down to how your CI/CD pipeline is architectured. Typically, what I've seen is some people run scans on Terraform code as early as possible, maybe in pre-commit hooks, or on every commit on every pull request, and then trying to run the Terraform scan on the plans a bit later on. So maybe in a nightly fashion, or in integration tests, thing like this. Yeah, typically, I think it makes sense to have different kind of scanning at different stages. Maybe also some strategy what I've seen is to scan for a very, very minimal set of checks very early on. Maybe scan for 5 very quick wins that are not going to be false positives and that are not going to be slow to scan, and then focus on maybe a wider picture a bit later on in the SDLC stage.
All right.
Do you? Oh, yeah. Okay. So from Magno, do you recommend any ISC scans for YAML files for Kubernetes cluster? Yeah, so I guess a lot of what we're discussing today for AWS is also very applicable to Kubernetes. To be honest, I don't have much experience on how to scan YAML files for Kubernetes cluster, but I guess a lot of it is also applicable. Typically, we're typically going to have Helm charts that maybe are heavily templatized. So we also have the challenge of, do we want to scan the Helm charts without any context? Do we want to scan them after they've been templatized? Or do we want to scan what is already running inside the Kubernetes cluster? So in my opinion, I guess it makes sense to try to have all of them. And it's basically kind of similar to Terraform if we want to scan the code, the plan, or maybe later on at runtime.
Yeah, there is OPA's Gatekeeper, which allows you to sort of webhook into the cluster and write your own rego or use pod security policy, to prevent misconfigurations from hitting the cluster. But yeah, I mean, I'll drop it in the chat because OPA is something that's I think is gaining more traction. at least in the Cloud Native Computing Foundation, and I think more broadly. And then Rego is the language that a lot of the OPA rules are written on, which is also what Regula is using. So I guess there's like, expansion of that happening. But OPA is great. I think it's a really great tool for Kubernetes pre-flight configuration checks. And it's very easy to break them, or just not let them on the cluster or warn. So it's relatively easy to implement.
Yeah, definitely. And also what's nice about Gatekeeper is that it allows you to have like a single choke point, basically. So you don't have maybe to go to each and every CI/CD pipeline. And you're sure that you can have this single enforcement point at the cluster level, which is very nice. But also it means that you're not really super left because when teams are hitting this, it might be already pretty late. Maybe they are already trying to deploy in production and they are getting blocked at this point. So I guess trying to have both early scanning and trying to scan things before they get in the Kubernetes cluster makes a lot of sense.
Yeah, there's a lot of tool sets around OPA too that you can use to scan the YAML files. So you can use Rego itself will also scan any static files. So you could, as you pointed out, you could write your own Rego rules and then scan the YAML. The other thing I've used is that Helm charts, if you're using Helm charts, you can use Helm unit testing. Any unit testing framework for YAML or the Kubernetes manifest will generally help. You can write your own policies and enforce them on the static files themselves. But there, at least from what I know beyond OPA, I'm not sure that there's anything that actually will scan the static files. You probably have to write those rules yourself using some other tooling.
Yeah, I'm not sure about that, but it's a great comment. Okay, so I think we can move on to the next one.
I just had one question.
Yeah, go ahead.
It's not really a question, but I really like your slides in terms of the research you've done and explaining, between code and plan and then all of the different tools. So this is a bit of a subjective question, but which is your favorite or which do you find is the most useful and kind of why? I appreciate there are lots of differences, but I'm just curious on your opinion.
Yeah, so I guess, but it's also a very personal opinion, and it boils down to what you are trying to achieve and what is most important to you. I like Chekhov because it allows to scan the plan and the code, and I also like everything that uses OPA because it's an open standard that is easy to test and that people are getting more and more familiar with. So I found Chekhov to be pretty easy to integrate in CI/CD pipelines. And TFSec, I found it to be specifically super blazing fast, like milliseconds. It's actually quite interesting. So if you have a big IRC repository, I guess it can be something that is super useful.
Awesome, thank you so much.
Cool. So let's get to the next part. So now we have our security baseline. So we know what we want to scan for. We have our Terraform scanning tool. We are at least aware of what we have in the open source landscape and what we can use for which purpose. Now, what next? Are we secure? Can we call it a day and just say that security is a success? In terms of expectations, this is our expectation here, our assumption that we have Terraform deploying to AWS with security checks in line. This is a bit too academic, right? Because if you look at any production environment, you have something like this. You have bash scripts also, you have manual changes, you have AWS console. Maybe you have some fancy self-healing infrastructure for Lambda functions that are going to create routes. Maybe you are creating Kubernetes ingresses that are going to dynamically provision load balancers or whatever. Some things that you can maybe only deploy with CloudFormation because the vendor is only giving you CloudFormation. Yeah, so looking at this, we see that Terraform is maybe only one part of the picture and that it makes sense to have some other visibility as well. And some famous last words from people, and this is some example that I stole from our guest that we'll have later on, Stephane. But basically, if you are a site reliability engineer, you are called at 3 a.m. and you want to debug a production issue. You're like, okay, I'll just open up port 22 on this security group just to make sure that I can access SSH just for 1 hour. Or maybe you have an application that hits a lot of permission denied issues, and you want to make sure it's not related to the IAM role, so you just attach temporarily administrator access. And you are confident that in any case, Terraform, like the next run of Terraform will override this because all your roles, all the security groups are managed by Terraform, right? And actually, it's a bit tricky because the logic that Terraform has is that when you run Terraform plan, it will compare what is in your code versus what is running in the account, but it's only going to do so for the resources that Terraform manages. And the trick here is that if you create a security group with Terraform, it might, depending how you define it, it will ignore any other ingress rule because it considers that it's not managing them. Same for IAM roles. It's not going to consider that any extra policy that you attach to the role is managed by Terraform. So a very practical example, say we have a security group, app SG, that is going to define an ingress rule to allow TCP traffic on port 443 from 10.0.0.0/16. Now, if we deploy it, we go to the AWS console. It looks like this. And if we go from the AWS console and manually we add a rule, okay, so we create a new ingress rule from anywhere to anywhere just for debugging purposes, and we save it. And then we run our Terraform plan. Terraform is going to tell us, no, it's fine. No worries, you didn't change anything. Everything is good. So that's the problem space that we call configuration drift. And it's basically, at some point, you had a specific state that was deployed in AWS. And as time goes by, this state, it drifted a bit from the expected state. So the problem is really trying to reconcile these two things and to have some visibility on what has drifted. So we have two things here: how to prevent the configuration drift and how to detect it. So to prevent it, the obvious thing is, which is very easy to say, is to try to lock down as much as possible the access to production environments. Typically, if our applications are deployed with infrastructure as code, operation people shouldn't have administrator level access to an account. Maybe they need a read-only access with a few specific permissions to scale up things or scale them down. Maybe they need a break glass account that they can use in case of something goes wrong. But if we cannot do this, or if we want a second layer of defense, we can also use service control policies on specific resources. So typically, we might have people that have a lot of permissions on the AWS accounts, and we can still deny them changes on maybe security groups or IAM users or IAM roles, which is very interesting because it allows us to make sure that our critical resources are not going to be changed manually. And obviously, the next one is to try to have as much as possible inside Terraform. Also, it's easier said than done, but we have some tools that can help us for that, typically Terraformer. It's a very nice tool from Google Cloud Platform, and it allows us to run Terraformer against an AWS account or an Azure subscription, and it will basically import all the resources that you are running there as Terraform code. So it's pretty powerful, and it can be a good starter. If you are given a huge AWS application that you want to migrate to Terraform. So this is for prevention. Now for detection, we have a few leads as well. So we have CloudTrail. CloudTrail, it's very nice because you can tell it, go and tell me in my production accounts what non-read-only things people have been doing manually. It might be something that we want to review on a daily, weekly, monthly basis. Also, as security people, it's nice to understand what people feel that they need to do manually to try to maybe come up with some solutions on, okay, how can we automate this thing? How can we give you maybe an interface to do this without having you touching things manually in production? And the other approach is to have some tooling that allows us to compare what is running live. with what we know or what we expect is a snapshot of like known good. And for that, we have a nice tool, driftctl, and we'll have one of the maintainers in the show very soon. And the way driftctl works is that it considers that the Terraform states are going to be your known good, and it's going to match your Terraform states against what you have running inside AWS, and it's going to give you three main things. First, what things are not managed by Terraform, which is interesting to understand, if there are some roles that you are missing in Terraform. Secondly, it's going to tell you what is managed by Terraform but has drifted from what you expect it to be. And third thing is what is managed by Terraform and hasn't drifted. So let's see a quick example. We can run driftctl. We give it our Terraform state. We can pass it multiple Terraform states as well, which typically is going to be the case because we're going to have a bunch of CI/CD pipelines deploying in the same account. So typically we need to use multiple states. We can also filter on a specific resource type if we want. So here I'm telling it, give me basically the drift state from for security group roles. And it's going to give me this information. So first one, it's going to tell me you have a security group role that you are not managing via Terraform. So it found this role in AWS, and it wasn't able to match it against something in my Terraform state. So it considers that the role has been deployed manually, which is super interesting for us. And it's also going to give us the coverage of the resources in the account that are managed by our Terraform states. And if some things have drifted from the Terraform states and what is deployed in the account. We'll get back to that in a few seconds, but a few notes also on runtime scanning. So, in terms of a journey, we started from how can we have some checks and some baseline that makes sense for our organization. Then how can we scan for that? And how can we make sure that what we have deployed is matching what we have defined in Terraform code? So kind of the last piece of the puzzle is really the runtime scanning. And if we have these three things, basically we are sure that we are writing secure infrastructure as code. We are sure that this is what is deployed. And we are sure that all the things that might be deployed in the account, maybe dynamically or manually, they are covered as well. So here, runtime scanning is really basically looking at what is deployed in the account and trying to find insecure things. So it's security on the right, but it's also quite important to do. So for that, we have some open source tools like Scout Suite, Prowler, Cloud Mapper, Cartography by Lyft, Cloud Planning, Steampipe. And we also have a lot of commercial solutions, a lot of them, but here I just listed AWS Config, Bridgecrew, DB Cloud, and Fugue. So this is a kind of a last line of defense, because if we are scanning something and we find a security issue there, it's already in production. It doesn't mean that we don't want to scan for that. It means that maybe we want to make sure we can fix the root cause before trying to find these security things. And in terms of challenges here, what we have mainly is the regions and the accounts. In AWS, we have a lot of regions in multiple AWS accounts, sometimes in multiple AWS organizations. And the runtime scanning tools, sometimes they only manage a single region, a single account, and changing to kind of orchestrate that across the whole thing. And something that also I'm super interested in, but that is very challenging, is we have a scanning pipeline for Terraform. Now we want to scan it at runtime, what is deployed. So how can we try to reuse the rules that we have for Terraform for runtime scanning? Because obviously, if we are trying to make sure that we don't have any public S3 buckets at the Terraform level, well, we don't want to have to write another set of rules for the same thing at runtime. And something that is a bit challenging, I don't have a silver bullet. There are a few commercial solutions that do support this. I think at least Fugue and Bridgecrew support having something like this. But generally, in the open source state, we don't have something that allows us to easily do that. So yeah, so I think we can expect to see some good projects in the future for that in the open source part. And now in terms of discussion, so we have Stephane Jourdan. He's one of the driftctl maintainers, and he's the author of the book Infrastructure as Code codebook. And he's here with us today to discuss anything about drift control, drift prevention and detection. And it's also very interesting because he's a guy with mostly an operations background. So he's not a guy with a security background. So I think it's very nice to have also his perspective on things.
Hello.
Hello.
Yeah, thank you for citing drift control and your interest in the tool.
Yeah, it sounds like a pretty new tool, actually. So, Stephane, this is a tool that didn't exist 1 year ago, right?
Oh yeah, it's really new. We released it. The first version was released at the end of December 2020. So it's a 3-month-old tool with 1,000 stars on GitHub. Yes,
pretty impressive.
Thank you.
Sounds good. So, can you share some plans or some things that you want to add to driftctl to make it, even more great?
Yeah. So yeah, drift control right now has some limitations, like it supports only AWS and GitHub providers. So we need to add more for other platforms like GCP and Azure. So go vote on the GitHub for there is a lot of GitHub discussions on the subject, so you can upvote the cloud providers that you want. And yeah, we are going through a major rewrite under the hood right now. We took some shortcuts to test the product at first. So we are relying on one single Terraform provider right now for all the calls and the checks. So right now we are doing it properly, so we can support any version of Terraform providers and not a single one. So yeah, that's the main things we are working on right now.
Cool. And do you have kind of stories from the trench about some drift control things that maybe as an operation guy happened to you in the past and that were very painful for you?
Yeah, like security slapped me in the face just because I didn't care. Yeah. Truth to be told, many stories came from people we interviewed as well when we were working on drift control previously. So we started by asking a lot of people in the field, like DevOps guys and SREs, that kind of things, and we asked them from stories from their trenches as well, and many came back as terrible stories because as professionals, we do not necessarily put security first in our daily jobs, even with Terraform and all the automation in the world. Well, if star works, then sometimes it's good enough to pass the weekend. So yeah, the examples you gave, like allowing SSH or even allowing anything to anywhere, I've seen it many times. Most recently, old S3 buckets were created until 2 years ago, I think. They were created as public by default, and you can very easily. There is a tool like Endgame, it's called. You can very easily pen test open S3 buckets, add a new account owner on it, and that's precisely the kind of things that would be detected by a tool like driftctl, because it's precisely not in Terraform. Even if you carefully crafted your S3 bucket on it, and it will never be reported because it's just a new object. It's a different thing from the AWS point of view. So it's all that that was really striking as a sysadmin, as a DevOps guy, when you thought you were doing the things correctly, but yeah, reality, exactly like your slide showed, reality is very, very different. as well. Like you are testing something, you click on the web console, you're happy, it works. You delete everything, you do it properly. Then on Terraform, it works, but it works because something else was created on the web console, and like, I don't know, an IPv6 rule or whatever it is, and then it works on your environment, and Terraform is cool, but then you promote it to staging or production or whatever environment next it is, and then it doesn't work, and you fail to deploy just because you tried something manually before. And Terraform is not a problem here. Terraform is a wonderful solution for automation, but it cannot know what you did manually. It cannot know what AWS is doing on your behalf when you click on buttons.
What are some of the sneakiest drift stories you have, like in terms of how you've detected or what you've tried to solve for in terms of drift entering the infrastructure? Like, is it always humans in the console, or is it some weird auto scaling thing or some weird API call that's spinning up new infrastructure? Like, what's the sneakiest drift story you've heard?
Yeah, that's an excellent question. Obviously, the most obvious ones are clearly about humans. That's always the weakest element of the chain. But we've seen recently more and more issues with authenticated applications, microservices, lambdas. They can do things by default. Let's say you have this microservice can read something and compare it to something else. But at some point, for some reason, I don't know, developers get bored waiting for credentials or something, and they know that this specific lambda or microservice can do things. And from there, they will abuse the microservice so they can create, I don't know, an object on S3 or whatever they can do. So it's just that they want to do the job faster, but that's a real world example I have from.
I guess you could call that privilege escalation through a Lambda function.
Exactly. You're right.
By feature.
Exactly. So that's definitely the kind of weirdest things we've seen. We've seen monitoring through billing as well. Like a team enabled the retention for S3, and but sadly it's not picked up by Terraform Apply unless it's explicitly mentioned. And too bad. The first week of the next month, the bill came in, and it was terrible. So yeah, that's monitoring through billing. It's quite interesting.
Nice. And I just wanted to highlight something that you said, which I find pretty interesting, is the fact that when we talk about drift, we can use it to detect things that were manually done, but we can also use it, like we can try to detect drift also to try to understand if someone malicious gained access to something and changes some settings. Like, I guess if you are sharing a S3 bucket with another account, and I think it's what you said, it can be also malicious, and basically having some visibility on the drift can also help for that. So it's just thought that it was an interesting comment.
Yeah, definitely. In fact, it's very same for IAM users. I personally had this issue. Like, you crafted your Terraform configuration pretty well. You have your IAM user, your keys. It's all interrelated. It's all good. And then for some reason, someone revoked the key on the web console and created a new one, added a new policy, etc. And it doesn't get picked up by Terraform either in most cases. So it's terrible, because you may end up with someone in your team working with rogue keys and with IAM policies that they were absolutely not supposed to have. So yeah, it's exactly the kind of things drift control is here for on the security side from an operation point of view. Yeah, definitely. And put it on CI, please. Get reports as soon as you can. It's very important.
Good. So thanks a lot, Stephane, for all these insights.
Thank you.
It's really nice, especially in a kind of DevOps show to have not only the perspective of the security guys, but say, yeah, you need to do this, but also to have some stories from people in the field. Yeah, so we have just a few closing slides, and then I think we'll be gone for today. Yeah, so there are some repositories that we can use, basically. So there are some repositories of code, of Terraform code, that is purposely vulnerable by design, which can be nice if you want to test some specific security tools and to see what they detect and how we can whitelist and things like this. So we have TerraGoat, which is done by Bridge Crew. They are the makers of Chekhov. And we have KaiMonkey, done by Accurix, and they do TerraScan. So this is something that can be nice and useful. And also a quick remark about these checks, basically that we have, when we say custom checks, it's really policy as code, and it shouldn't just be a buzzword, because when we say as code, it also implies that we need to test it. So typically, it's super useful to have a unit test next to our rules. So if we write it in Python, we can use PyTest, for instance. If we use the Rego language, we can use Frego. It's a testing toolkit for Rego. And yeah, and typically it's nice because it means that when you find a false positive or a false negative and you want to fix it, well, you can fix your rule in a commit, and you can also have a regression check to make sure that when you change the rule in the future, basically it won't happen again. So yeah, just something to consider, that it makes a lot of sense in some cases to have the custom checks, the rule in a single repo that is a version with tests, and that basically is handled as code. So I hope it was useful. I hope you liked it. You can find the slides here, bit.ly devslop IRC scanning slides. And you can find the DevSlops episode on their website. They have a lot of great episodes. I still need to watch them, but they're like basically all of them are great. So I really encourage that you take a look. And if you want to give me a few feedback for improvement for the talk, feel free to go to this link and to reply to the form. So yeah, thanks a lot, and thanks a lot for the host today.
Yeah, thank you. Rosemary, jump in.
Yeah, why not?
Yeah,
I think
go
we
for
still have one more in the chat. And just so since we're all here, someone asked, what is the soundness and completeness of these tools that shift security to the left in the cloud?
Well, it's a good thing we have Stephane here, so he could help us understand how well maintained they are.
Well, in the case of driftctl, we are still working on it, so definitely it's not as complete as other tools. We try to do it the best we can, using the more automated ways possible. But yeah, we will always we may have the same issue that tools like Terraform have, like you will always be probably days or weeks late behind AWS releasing a new service, and they release services every 2 days. So that's a lot of work, and we are 5 people developers. So yeah, but it's getting better every day, and open source. So as it's open source, you can prioritize with us and give a hand if you want, and join our Discord if you want.
Yeah, and if we also take the same question about the soundness and completeness for the Terraform scaling tools, if we assume that soundness means the rate of false positive and completeness means the rate of false negatives, I guess it boils down to also what you are scanning, right? Because if you are trying to scan for everything, most likely you're going to have a lot of noise. But if you focus on kind of more narrow things that are high value and that you know are going to be detected, probably you're going to end up with less false positives and less noise. And in terms of completeness, it's mostly going to boil down to the set of checks that the tool has by default, which can vary a lot, as we saw in the slide. But I also personally don't think that it's a great idea to just throw hundreds of checks at a Terraform code without really knowing what it is scanning for.
Yeah, makes sense.
Cool. This
Cool.
isn't a question, but I'd just like to say thank you so much, Christophe, because I've really enjoyed. You've done a lot of research into the different kind of tools, so it's a really useful asset. And also Stephane as well for all of the war stories and telling us about driftctl. It's been, I personally, I'm sure everyone's loved it, but I've really enjoyed it.
Cool, thank you.
Yeah, same here. This has been great to like learn about all these tools in the deep dive. I liked your matrix around what they support versus what they don't support. I'm definitely going to take that one. But yeah, all the slides are in the show notes and they are also in the chat. So anybody who wants to refer back, and I think everyone knows where to find you on social media. I think that was also in your slides, but if you want to just quickly shout out your Twitter handle and how people can contact you, I think we could wrap this up.
Yeah, sure. I'm Christophe TD on Twitter. My DMs are open if you want to talk about anything that is related to that or share your experience. And I have a blog as well, blog.christophe.fr. I try to write on it. Most of the time it's a failure, but I try to get at least a few blog posts per year out. Yeah.
Cool. All right. Thank you, guys. Thanks, Stephane, for joining and giving us your perspective. Thanks, Christophe. Thanks, Rosemary. Thanks, Stefania. Thanks, Nancy.
Thank you.
Thank you.